Welcome back, everyone, to the Deep Dive. Today, we're going to be looking at AI data centers, and specifically this project that's been in the news lately, this Stargate thing that
Right.
Microsoft and OpenAI are supposedly working on. There have been some leaked reports suggesting they might invest like $100 billion into it,
100 billion.
which is just
It's
an
wild.
insane amount of money.
It is.
More than double
Yeah,
what Amazon said they're going to spend on AI infrastructure over the next 15 years.
totally.
So it seems like something pretty major is happening here.
Yeah, no, it's absolutely massive, this Stargate project. I mean, that's enough money to buy a small country for that kind of investment.
Yeah.
So the question is, what's driving this? Like, why are they putting so much into it?
Right before we get too deep into Stargate, though,
hmm
can you remind me what exactly a data center is in this context? And how is that different from, like, the data centers that power our favorite websites and stuff?
Yeah, good point. It's easy to get caught up in the hype. So basically, a data center is just a facility with a ton of computer servers all connected together. They're kind of the backbone of the internet, right? They store and process all this information. But AI data centers, they're on a whole other level. They're specifically built to handle the insane amount of computing power that AI needs. Like, it's a completely different beast.
Okay, so not just your average server farm. Our sources keep mentioning AI accelerators, too. What exactly are those, and how do they fit into all of this?
Okay, so imagine you're trying to teach a computer to recognize a cat in a photo. Sounds easy enough, right?
Hmm.
But that actually involves analyzing millions of images. The computer has to pick out patterns, do these complex calculations. AI accelerators like Nvidia GPUs, which are really popular right now, they're chips that are designed to do exactly that kind of heavy lifting. They're basically the engine driving AI's learning process.
Gotcha. So more power equals AI can learn faster and do more complex stuff. But to justify a $100 billion investment, we're talking about a lot of these AI accelerators, right?
Oh, yeah, you're totally right. We could be looking at like 25,000 to 50,000 of these AI accelerators in just one data center.
Wow.
And that's just for $1 billion one. But
Right.
for Stargate, you got to think 10 times bigger than that. It's an absolutely insane amount of processing power, all dedicated to just pushing the limits of what AI can do.
My head's spinning.
hmm
But I imagine building one of these things isn't as simple as just plugging in a bunch of servers and calling it a day, right?
Right.
What are some of the challenges Microsoft and OpenAI might face with Stargate?
Yeah, you're hitting on a really important point. Building an AI data center is a massive undertaking. It's way more than just the number of servers. You have to think about power consumption, cooling, networking, making sure the whole thing doesn't like melt down or collapse in on itself.
Okay, so Stargate is more than just a server warehouse. Let's break down these challenges. First, power. I read somewhere that they might even be considering nuclear power to keep the lights on. Is that for real?
hmm
And what about the environmental impact of something this big?
Yeah, power is a huge concern with AI data centers. I mean, Stargate, at its potential scale, could draw as much power as a small city. Now, the idea of a nuclear-powered data center sounds kind of crazy,
Right, I
right?
know.
But it shows you just how much energy we're talking about. The good news is that there's this big push towards renewable energy sources in this space. Like Amazon, for example, they're already at 85% renewable energy for their data centers. And they've got these ambitious plans to go even further.
That's good to hear. But even with renewable energy, keeping all those servers cool must be a huge challenge, especially if Stargate ends up in Arizona, like some reports are suggesting.
Oh, absolutely. Cooling is usually the biggest expense for data centers. Sometimes it even costs more than the energy to run the servers themselves. Just imagine trying to keep a city's worth of computer processors from overheating. It's not an easy task. Traditional methods involve a lot of water cooling, but with something like Stargate, they'll probably have to come up with some pretty innovative solutions. Maybe even something we haven't even thought of yet.
Speaking of innovative solutions, our sources mentioned that Google, another big player in AI, they don't seem to be as worried about keeping their servers cool. They're okay with them running hotter than most companies would be comfortable with. Is that just to save money, or is there something else going on there?
It's an interesting approach for sure. Google is known for its engineering,
Yeah.
and they've historically used cheaper, less durable machines and run them at higher temperatures. Their philosophy is basically that they're so good at dealing with failures that they can push their hardware further without risking major problems.
That's pretty bold. But aside from keeping the servers from melting, how do you even connect thousands of these powerful machines together?
Mhm.
I can't imagine a normal internet connection would be enough.
You're exactly right. Networking is essential for data centers, and it's even more critical when you're talking about AI. We might be impressed by gigabit internet at home, but inside these data centers, data is flying around at 400 gigabits per second, or
Got
even
it.
faster.
Wait, that's like hundreds of times faster than my internet at home. Why does AI need such a crazy fast connection?
Think of it like an orchestra. Each AI accelerator is like a musician playing their part. To make beautiful music, they need to be perfectly in sync, communicating with each other constantly. Similarly, those thousands of AI accelerators need to be talking to each other all the time, exchanging data, coordinating their calculations. And that requires incredibly low latency and massive bandwidth, way more than your typical internet connection can handle.
So it's not just about how powerful each individual piece is, it's about how well they can all work together. And speaking of working together, what about redundancy? If one part of this massive system fails, does the whole thing come crashing down?
That's a crucial consideration.
Right.
Resilience and redundancy are absolutely essential when you're dealing with something this complex. I mean, imagine if a power outage or a server failure took down an entire AI data center. You could have huge disruptions to research development, even critical services that rely on AI.
Yikes, that's not good. So how do they build in this redundancy? Is it about having backup generators, extra cooling systems,
Yeah.
spare servers ready to go?
Exactly. Redundancy is all about having backups for every critical component. So if one part fails, the others can keep things running. They also use multiple data centers in different locations so that if one gets hit by a natural disaster or whatever, the others can take over. It's all about spreading the risk.
So they're building a digital fortress, basically prepared for anything.
Yeah.
But let's shift gears a bit and talk about the brains of the operation, the hardware and software behind all this. Our sources point to a pretty intense competition between two main players, Nvidia and Google. What makes them the leaders in this space?
Both Nvidia and Google have been hugely influential in AI. Nvidia with its GPUs and this programming language they created called CUDA. They've pretty much dominated the AI accelerator market for years now. They've built this whole ecosystem that gives developers a lot of control and lets them squeeze out every bit of performance from their hardware.
All right, I've heard of CDA, but I never really understood what it is or why it's so important. Can you break that down for me?
Yeah, so think of CUDA as like a special language that lets developers talk directly to NVIDIA's GPUs. It gives them fine-grained control over how the chips process data. It's become so ingrained in AI that most of the popular deep learning tools were originally designed to work exclusively with CUDA.
So to use NVIDIA's GPUs, you basically need to speak their language. Makes sense, but it also sounds like it could give them a bit of a monopoly, wouldn't it?
Exactly, that's the thing. While CUDA has definitely contributed to NVIDIA's success, it's also created a situation where developers and researchers have become heavily reliant on their platform.
So where does Google fit into all of this? They don't use NVIDIA GPUs in their data centers, do they?
Nope. Google has gone its own way, developing their own custom-designed AI chips called Tensor Processing Units, or TPUs for short. And they control the entire ecosystem from the hardware to the software, which gives them a lot of flexibility and potential for optimization.
It's like a classic David versus Goliath story. NVIDIA, the established giant with its CDA-powered GPUs, and Google, the tech behemoth, with its custom-built TPUs. It'll be interesting to see how that competition plays out.
It's a fascinating dynamic for sure. But the competition isn't just about the chips themselves. It's about building a whole ecosystem. The software, the tools, the frameworks that attract developers and make it easier to build and use AI applications.
So it's a multifaceted battle with hardware and software both playing crucial roles. And this Stargate project from Microsoft and OpenAI is right at the center of it all. Their choices about hardware-software, the entire infrastructure could have a ripple effect throughout the whole AI industry.
Absolutely. Stargate is like a high-stakes poker game with billions of dollars on the line. The decisions they make could determine the future of AI development, who controls this powerful technology.
This is shaping up to be an epic deep dive, and we've only just scratched the surface. But before we get into the nitty-gritty of NVIDIA versus Google and explore the mysteries of Stargate a little further, let's take a quick breather. We'll be back in a flash to continue our exploration. Welcome back. Before the break, we were talking about NVIDIA's CGA and how it's become so essential in AI. It's amazing how a programming language can shape the hardware landscape like that.
Yeah, I'm starting to see how deeply connected they are, but some of our sources suggest that this heavy reliance on CDA might actually be turning into a problem for NVIDIA. How could something that's been such a strength for them become a weakness?
Well, imagine building a castle on a single foundation.
Hmm.
That's kind of what Nvidia has done with CUDA. For years, it's been their rock, but now some cracks are starting to show.
Cracks? What kind of cracks?
New technologies are popping up that could shake things up in this CUDA-centric world, and that's making some people nervous, especially those who've bet big on Nvidia. So it's like a potential paradigm shift in AI hardware. What are these new technologies that are causing all this disruption?
One of the key things is the rise of this thing called the LLVM compiler framework. Think of it as a universal translator for programming languages. It can take code written in different languages and convert it into this optimized machine code that can run on different types of hardware.
Our sources mention that LLVM is used in all sorts of applications, from web browsers to operating systems. It sounds incredibly versatile. But how does this relate to Nvidia and CUA?
That's where things get interesting. Projects like OpenAI's Triton are using LLVM to bypass CUDA entirely. Triton lets developers write their AI code in Python, which is super popular these days, and then compile it directly into machine code that runs on Nvidia GPUs without ever touching CUD.
So they're cutting out the middleman. No more need for this special CUDA language.
Exactly, and this is a big deal because it shows that you don't necessarily need CUDA to get great performance out of Nvidia's GPUs. But what makes Triton even more interesting is that because it's built on LLVM, it can also be adapted to work with other types of GPUs.
Okay, so Triton can potentially break free from the whole CUDA ecosystem. But why would OpenAI, who are partners with Microsoft on Stargate, even be interested in this?
Well, if you're dropping $100 billion on an AI data center, you probably don't want to be stuck with just one hardware vendor. Having options and flexibility is crucial. That's why OpenAI's exploration of these CUDA alternatives, like Triton's recent support for AMD GPUs, is so significant.
Ah, I see where you're going with this. So AMD, the underdog in the GPU world, could actually be a contender for Stargate. That would be a huge shakeup.
It would indeed. And it's not just OpenAI. Other big players in AI are also moving towards more hardware-agnostic approaches. PyTorch, for example, another popular deep learning framework, is becoming more compatible with different GPUs, including AMD's offerings.
So the winds of change are blowing through the AI hardware world. CUDA's dominance might be fading as these new players and technologies emerge. But Nvidia isn't just going to roll over, are they?
Of course not. They're a powerhouse with a ton of experience and innovation behind them. They're constantly releasing new and more powerful GPUs, and they have this huge community of developers and researchers who are deeply invested in their platform.
It's turning into a classic battle of the titans, the established giant versus the agile upstarts. But in the tech world, things can change so quickly.
You're absolutely right. The race for AI dominance is far from over, and it's going to be fascinating to see how it all unfolds.
Speaking of fascinating, what about Google and their TPUs? We haven't talked about them much yet, but they're obviously a major force in this space. How do they stack up against Nvidia and AMD?
Google's TPUs are kind of their own thing. Unlike Nvidia and AMD, who are mainly focused on general-purpose GPUs, Google designed TPUs from the ground up, specifically for machine learning. They control the whole stack, the hardware, the software, everything. And that lets them optimize for performance and efficiency in ways that other companies just can't.
So it's like a custom-tailored suit versus something off the rack.
Perfect analogy. TPUs have a different architecture than GPUs, and they excel in specific areas, especially when it comes to training these large language models.
Our sources mention something about a unique microarchitecture that gives TPUs an edge. Can you explain what that means in simple terms?
Imagine a factory with assembly lines designed to make a very specific product. That's kind of how TPUs work. Their architecture is optimized for these things called matrix multiplications, which are the core of deep learning.
Ah, so they're built for a very specific purpose and they're really good at it. But if TPUs are so great, why isn't everyone using them? Why is there even a competition with Nvidia and AMD?
That's a good question. While TPUs are super powerful, they're not as readily available as GPUs. Google mostly offers them through their cloud platform, and they haven't been as aggressive in marketing them to a wider audience.
So it's like a walled garden. You have to play by Google's rules if you want to use their TPUs.
You could say that. And that's been one of the hurdles for Google in getting more people to adopt TPUs, but they have been making efforts to make them more accessible and developer-friendly in recent years.
Sounds like we're witnessing a three-way race in the AI hardware world. Nvidia, the established powerhouse, with CD, AMD, the underdog, trying to shake things up, and Google, the tech giant, with its specialized TPUs.
It's a dynamic and constantly evolving landscape, and whoever comes out on top will have a huge impact on the future of AI.
And speaking of the future of AI, let's bring it back to Stargate. This massive $100 billion project is a clear signal that Microsoft and OpenAI are all in on AI, and their choices about hardware and software will send ripples through the entire industry.
Absolutely. Stargate is more than just a data center. It's a statement. It's saying that AI isn't just some niche technology anymore. It's the future.
So as we head into the final part of our deep dive into Stargate, keep this in mind. The decisions made about this project could shape the trajectory of AI for years to come. But before we get there, there's one crucial question we haven't really addressed yet.
I'm all ears. What is it?
We've talked about the challenges of power cooling networking, but we haven't really delved into the software side of things. What are the key software considerations for a project like Stargate? What are the tools and technologies that will make this massive AI brain actually work?
That's a great segue into the next part of our discussion. The software stack is just as important as the hardware when it comes to AI. We need to talk about deep learning frameworks, computational graphs compilers, the tools that developers use to harness the power of these massive AI systems.
Sounds like we're about to enter a whole new level of complexity. But hey, that's what the deep dive is all about, right? Exploring the cutting edge of technology and unraveling the mysteries behind it. We'll be back in a moment to continue our journey. Welcome back to the deep dive. Before the break, we were teasing this big question, the software side of Stargate. We talked about the hardware, the scale, all that, but what about the actual tools, the code that's going to make this $100 billion investment actually think?
It's a critical piece, right? Building an AI data center isn't just about the hardware, it's about creating an environment where AI software can really thrive. So to understand the challenges Stargate faces, we got to talk about the tools they'll use to actually develop, train, and deploy these AI models.
Okay, so break it down for me. What are the software building blocks for something like Stargate?
Think of Stargate as this giant digital brainwright. The hardware with all those AI accelerators provides the raw power. But to make this brain work, we need specialized software. It's like the network of neurons and synapses that let a brain learn, reason, solve problems.
I like that analogy. So what are the key software pieces driving this digital brain?
First, you have the deep learning frameworks. These are like the operating systems for AI development. They provide the tools, the libraries that researchers and developers use to build, train, and deploy AI models.
Our sources mentioned two big names, PyTorch and TensorFlow. Can you give us a quick overview of those and how they might fit into Stargate?
Sure. PyTorch and TensorFlow, they're like the Coke and Pepsi of deep learning, both super powerful and popular, but with their own strengths and weaknesses. PyTorch is known for being flexible and easy to use, which makes it popular with researchers. TensorFlow, on the other hand, is really strong in production environments and scalability, which is essential when you're deploying AI models on a massive scale.
So depending on what Stargate is ultimately designed to do, they might choose one over the other or maybe even use both.
Exactly. And that choice has implications for the entire software stack. Remember, we're talking about unprecedented scale, so the software has to be robust, efficient, able to handle insane amounts of data.
Speaking of massive amounts of data, how do these frameworks actually process all that information and make it useful for AI? Our sources mention computational graphs and compilers. Those sound pretty intimidating.
They might sound complex, but the ideas are pretty straightforward. Imagine you're building a Lego model. You have all these individual bricks, and you follow instructions to put them together into a specific shape.
Okay, I'm following so far.
Well, in AI, a computational graph is like that set of instructions. It represents all the math, the operations involved in an AI model, defining how data flows through the system and how calculations are performed.
So it's a visual representation of how the AI model works.
Exactly. And that's where compilers come in. Think of a compiler as a master builder that takes that computational graph, optimizes it, makes it efficient, and translates it into a language the hardware can understand.
So it's like a bridge between the abstract world of the AI model and the physical world of the hardware.
Perfect analogy. The compiler makes sure the AI model can run smoothly and efficiently on whatever hardware they choose, whether it's Nvidia GPUs, AMD GPUs, or Google's TPUs.
This is starting to sound like a symphony of software and hardware working together to create something amazing. But with so many moving parts, there must be a conductor, right? Something that orchestrates the whole process.
Absolutely, and that's where specialized software tools come in. Tools for managing the data monitoring performance, debugging code, and basically making sure the whole system runs without any hiccups.
So it's like a high-tech control center for the entire AI data center.
Precisely. And for something as massive as Stargate, these tools have to be incredibly sophisticated and robust. They need to handle the complexities of coordinating thousands of AI accelerators, managing petabytes of data, and making sure everything runs smoothly.
It sounds like building Stargate is like putting together a giant complex puzzle with both hardware and software pieces that need to fit perfectly.
That's a great way to put it. The success of this project depends not just on the individual parts, but how well they all work together.
It's a massive undertaking, but the potential payoff is huge. We're talking about potential breakthroughs in AI, new discoveries, innovative applications, maybe even a deeper understanding of intelligence itself.
The possibilities are mind-blowing. Stargate could usher in a whole new era of AI, pushing the boundaries of what's possible and shaping the future of technology as we know it.
It's exciting and a little bit scary to think about the implications, but that's the beauty of the deep dive. We get to explore these complex topics, unravel the mysteries, and hopefully gain a better understanding of what's shaping our world.
And as we wrap up this deep dive into AI data centers, I want to leave our listeners with one final thought. The scale and ambition of Stargate are undeniable, but it's important to remember that technology is a tool. It's up to us as a society to decide how we use it, what values we embed in it, and what kind of future we want to create with it.
That's a powerful message and a perfect note to end on. The future of AI is in our hands. Thanks for joining us on this incredible journey into the heart of AI infrastructure. We'll see you next time on The Deep Dive.